Hello and hi. So today we are going to present to you about amplitude modulation, angle modulation, and radio digital modulation. So without further ado, let's get started.
Amplitude modulation is a technique used in electronic communication, particularly in transmitting information through radio wave. In amplitude modulation, the amplitude of a carrier wave is varied in proportion of the waveform of the message signal, which can be audio, video, or any other form of data. And then we have type of AM signal. The first one is double sideband full carrier, DSBFC. The second one is double sideband suppressed carrier, DSBSC. And the third one is single sideband, SSB. The fourth one is single sideband suppressed carrier, SSBSC. And the last one is vestigial sideband, VSB. Okay, the equation for DSBFC, V equals to EC plus EM cos omega MT cos omega CT. For DSBSC, V equals to EM cos omega MT cos omega CT. And the last one is SSBSC, V equals to EM over 2 cos omega MT cos omega CT plus minus EM over 2 sin omega MT sin omega CT. So we go to the uses of amplitude modulation. The first one is AM radio broadcasting, transmitting voice and music over long distance. The second one is two-way radios, used for communication between people or device over short distance. And the last one is aerospace communication, communication between aircraft and ground control.
Today, I will be discussing an essential concept in communication systems, angle modulation. This technique is crucial for transmitting information effectively over long distance while maintaining signal integrity. What is angle modulation? Angle modulation refers to the process of varying the angle of a carrier wave based on baseband signal that carries information. This method allows us to encode information in the frequency or phase of the carrier wave. There are two primary types of angle modulation. First is frequency modulation, FM. In FM, the instantaneous frequency of the carrier changes according to the amplitude of the message signal. Second is phase modulation, PM. In PM, it is the instantaneous phase of the carrier that varies, while its frequency and amplitude remain constant. Angle modulation has several important characteristics. First is nonlinear nature. Unlike amplitude modulation, angle modulation is nonlinear, meaning its bandwidths depend on factors that like modulation depth rather than just the bandwidth of the baseband signal. Second is power efficiency. A significant portion of transmitted power resides in the sidebands, making angle modulation more power efficient compared to AM. And lastly, bandwidth requirements. Angle modulation generally requires a larger bandwidth but can convey more information within a given frequency range. Angle modulation techniques are widely used in various applications. First, for FM radio broadcasting. Due to its noise resistance, FM is extensively used for audio broadcasting. Second, for television broadcasting. Both FM and PM crucial roles in video transmission. And lastly, for satellite communication. These techniques help maintain signal integrity over long distance.
So now we're going to talk about radio digital modulation. Digital modulation is the process of converting digital data into a modulated signal by varying one or more properties of a carrier wave, such as amplitude, frequency, or phase, to represent binary data. Some characteristics of it is first, discrete states. Digital modulation uses discrete states or symbols to represent bits. Each state corresponds to each specific amplitude, frequency, or phase of the carrier wave. Then, clock synchronization. The modulation process is synchronized with a clock signal, ensuring that the states are established at precise intervals. Next, noise immunity. Digital modulation techniques are generally more resistant to noise and interference compared to analog modulation methods, making them suitable for high quality communication. These are some common types of digital modulation. First, we have ASK, amplitude shift keying. The amplitude of carrying wave is varied according to the digital signal. Simple but sensitive to noise. Next, frequency shifting. Frequency shift keying, FSK, frequency of the carrier wave change based on the digital signal, more robust against noise and require greater bandwidth than ASK. Then phase shift keying, PSK. The phase of carrier wave is altered to represent digital data, more complex and allow for higher data rates compared to ASK and FSK. Application for radio digital modulation. First, we have telecommunication, used in mobile network, satellite communication, and digital broadcasting. Then, data networking, essential for Wi-Fi, DSL, and other broadband technologies. And next, digital audio and video, employed in digital radio and television broadcasting. That's all from us. Thank you so much.